we have the limit as x approaches 0 of sine x over 3 roots of x. And we do the direct substitution, plugging 0 directly in. We end up with sine 0 over 0. So we end up with 0 over 0, and that means that we need to try to factor, do some kind of trick we've learned earlier. And this one here is definitely going to be a trick. And this is what I'm going to do. I'm going to write sine cubed x here. In other words, multiplying the top, or cubing the top, and then end up cubing the bottom. Now this is 3 roots of x, so I can rewrite this as x to the 1/3 power. But if I cube the top, I must do the bottom also. And then what I'm going to do is raise all of this to the 1/3 power. So you see 1/3 times 3 is just 1, and we end up with sine x, and then we have x right to the 1/3, which is raised to the third, and 1/3 times this 3 is, we just end up with this. So this is the trick that we're going to use here. Now, I'm going to take these brackets here and bring it completely out. This was one of the properties of limits that we talked about in some earlier problems. So I'm going to rewrite this limit as x goes to 0 of sine cubed x over x. Now 1/3 times 3 is just a 1 right here. So now you can see that, and remember all these limits are equal to each other. We need to kind of keep that in mind. Okay. Now what I'm going to do here is I'm going to break this up inside here. So this is sine x over x times sine squared x. And let's keep this in mind that everything inside here is all raised to 1/3 power. Now remember, by the definition that we learned earlier, that the limit as x goes to 0 of sine x over x is defined to be 1. And that we directly substitute 0 in for the sine x here, we end up getting 0. And remember that this is all still raised to the 1/3 power, and 0 to the 1/3 is just 0. So our original limit that we started off with is equal to 0.